So now that we've gone through that exercise, let's put these pieces together. We showed 3 separate results: that being able to find the best or nearly the best lets you make few mistakes. Being able to make few mistakes lets you do well on average per step. Being able to do well on average per step gives you the ability to actually find a nearly best arm. So all these things are actually equivalent. If you give me an algorithm for doing any one of these, I can derive something for doing the other 2. Just kind of do it in a circle here. So in a sense, what this is telling us is that we kind of don't have to pick among these 3 different optimality criteria because they're really all the same as each other. And you could sort of say, well, and must be that these are the right ones to think about, because even if we don't think about, say, this doing well on average per step, we would have to solve it anyway if we cared about any of these other things. So I don't know. I mean, what I get out of this is the idea that whichever of these is most convenient for you to work with, you should just work with it, because the other ones are going to fall out. And there's other optimality criteria that you could worry about, but I don't know. It seems like a lot of them come back down to these.
Yeah, I like that a lot. You're really saying that they're kind of in an equivalence class of difficulty.
Yes. Now, interestingly, the thing that we haven't done yet and that we need to do is show that we can solve any of these problems.
I thought we just did. We did put a lot of words on some screens, and there were some towels.
No. No, what we showed was that if you could solve one, you could solve the other. If you could solve that one, you could solve. But we never said that any of these are actually solvable. And so we need one more result to kind of make this all doable.
Okay, that's fair. But so, I don't know. I was satisfied with proof by tau. But if you want to, actually go and ground it out.
Yeah, but all the taus were defined in terms of other taus. It never bottomed out. Right? What we'd really like is something that says, here's an algorithm that will, in a polynomial number of trials, find you a nearly optimal arm.
I don't know, Michael. It seems to me this is pretty straightforward. It's taus all the way down.
It can't be taus all the way down.
Why not? It's turtles. They start with the same sound.
That's true. I guess they're Greek turtles.
Yes, it's Greek turtles all the way down, which is what we've always suspected.